Hello, and welcome back to AP Environmental Science. Today, what we want to talk about is solar power. And you, of course, are looking at a picture of Thomas Edison. And he had this to say about solar power. And I think that this is a really interesting thing because he made this quote in the early 20th century. This idea that the sun is a really, really good source of energy. And we have not really taken advantage of solar energy, and that's a real shame because there are huge environmental benefits. There are some environmental disadvantages as well, and we'll talk about those, but overall, it's really beneficial. Solar power is renewable, and there's several other renewables as well. And so the benefits that we're talking about now are kind of benefits of all renewable sources, but today we are focusing on solar power. It is sustainable. That is what renewable means, and that means that there's no limit to what you can get, which means that you have energy security, and that creates a much more stable environment, especially when you're talking about foreign relations. It also creates jobs in industry. One of the big arguments is that, oh, if we have renewable energy, we won't have jobs. But even though it's a renewable source, you still have to harness it. You still have to make the things that harness it. And so there's always going to be jobs in industry associated with this. And the other thing that's really important is that they are not fossil fuels. They do not release CO2. They don't release pollutants, typically, and they're going to last forever. So, renewables. But today, solar power, and in an hour, the Earth receives more energy than what we use in a year, right? And so there's all of this energy that is striking the Earth's surface, and we're just not using it. As a matter of fact, if we wanted to produce all of the electricity that we needed for the entire United States, we would just have to have a 10,000 square mile area of Nevada, right? And so it really turns out to be this little square right here. Interestingly enough, this is about the same size of an area that we would need for a wind farm that would do the exact same thing. And so you can imagine how powerful it would be to have a combination of those two things. But we'll talk about wind later on. So back to solar power. Well, where do we find all of this? By the way, this is where that little square was. So when you look at solar power, obviously places that get more sun are going to be places that are going to have more potential. However, the question becomes, is it possible to use solar power in places like, say, Seattle, right, in the Pacific Northwest, over here up in New England, in places where it's not as sunny all of the time? And that's one of the things that you're going to be investigating in your lab, right? Where the question is, how can we power the world with solar power? Okay, now, first of all, we've been using solar energy for a really long time, for thousands of years, in the form of passive solar heating. And basically what this is to let the sun do the work of heating stuff up. And that's great, and because the sun does that all by itself. But you can maximize how much heating you can get out of the sun with three key design elements of your structure. That is insulation, collection, and storage, right? And so when we talk about passive solar heating and cooling, one of the very simplest things to do is just construct an overhang that is at the right angle, right? And so you have the summer sun, if you have your nice little overhang in the right place at the right distance to the window and all this good stuff. You have it blocked in the summer, but then when the sun is lower in the winter, the light shines right through, and the window lets visible light come in, but then as it passes through, it changes frequency and is now infrared heat, some of it, right? And so it can't travel back through, and so glass is a really great way to store the heat in that room, to keep it in there. And so it works like insulation, okay? Now, the other thing is you want to have actually good insulation. But here's a really good example of a nice house. This is xeriscaped, by the way, so this is native vegetation. And then you have these big, beautiful windows that allow sun blockage when the sun's coming in from the summer, and then when the sun is in the winter, right, shines right through these windows, big plate glass, keep the heat in. Okay. Now, that's passive because the sun just does what it does. Now, you can actively collect solar energy for heating. And we're talking about heating. We'll talk about electricity in a little bit, but solar is good for not just electricity, it's also good for heating. So we're going to start with heating because that's what we've been doing for a long time. The Romans in the Roman baths, they actually put glass in the windows, and they had these like solar, bathrooms that were called the heliocometi, and that is because they had the sun trapped inside the building with the glass. It's very exciting. Anyway, back to this active solar heating. That was all passive. Active is where you are going to have some sort of collector, right? A collector system. And that would be some sort of black or dark surface that is behind glass, because black absorbs, think albedo, it's going to absorb the light that's falling on it, and so it's going to heat up. And this is the active portion of it. You're changing what you're getting out of it by manipulating the surface that it's falling on. And you can actually get huge heat differences with this. The trick is to minimize the thermal loss, and so you have to build something that is not going to lose heat. But a really common solar water heater that you would find are going to be these flat plate collectors, and this is a black box, right, that's covered with glass, and inside there are tubes that have water through them. And if you were to put this on your roof, and lots of people actually have these all over the world, because they're free in terms of the heating, and that's very exciting. And you can have them anywhere. You don't have to have electricity to run it. You don't have to have natural gas like most of us have in our hot water heaters. You don't need any of that, okay? So anyways, here's the collector. The water comes through. It heats up. It comes back down into the home, into a heat exchanger, where the heat is taken off of that pipe, right, that's got the water in it, or whatever it could be. It could be a hydraulic fluid, or a fluid, right? It could be anything. And then it's cooler and it comes back up here. Well, now this is storing the heat, and you can use that water for things like showers or whatever. And now you may have to have an auxiliary heater, could be a tankless water heater, something like that. But you will have done most of the work with this nice little flat plate collector. Okay, now here's just an example of a solar water heater. You can see that it is just that, a box with glass on it and pipes in there. Okay, now when we talk about this heat that's available, we can use that heat, right, that active collection of it, to heat up water to what? To make steam, to turn the turbine, to turn the magnet, to create the current that goes to your house. Now we're talking about electricity production, and this is also an active process. So that flat plate collector is active heating. This is going to be active heating to produce electricity. And the devices that do this, there are really two big ones. There are the parabolic troughs, and there are the like the power towers, the mirror collectors. Okay, and so here in a parabolic trough, this one's tricky, and these are kind of expensive because you have to have a parabolic mirror. And if you think back to physics, when you were doing optics and lenses and things like that, parabolic mirrors will focus all the light to a single focal point. And you can see this glowing rod down the center. This is not actually generating light. This is light reflected off of this parabolic trough. So all of the sun is focused. And if you think of magnifying glass on a dried leaf setting things on fire, you are talking about this system right here. You focus the light onto some sort of fluid that is going to flow through these pipes, and then it is going to go into a heat exchanger, right? Just like everything else. Here you go. And it's going to heat up water, and that water is going to make steam, and that steam is going to turn the turbine, right, etc., as we talked about before. Now, you have all of this hot water that's built from this, built up from this, okay? And of course you have to send it to cooling towers. But in some instances, I mean, keep in mind that you can use solar power it doesn't have to be on a commercial scale. It could be on a single building. So let's say that you have your parabolic trough or whatever, and you heat it up and you want to generate electricity. You can also use the waste heat to actually heat the building, and that's pretty exciting. And when you do this, you're using a system to make two useful forms of energy, in this case electricity and heat. That is called cogeneration. Okay. Now, here is a commercial plant. Like I said, you don't have to have a commercial plant. You can. The nice thing about solar is it can be individual or it can be commercial, right? And so here you have this giant group of parabolic troughs, okay? And this is actually in California, and it supplies Los Angeles. Now, here's another one in California that's in Barstow, and this is called a power tower. And instead of having the really expensive parabolic mirrors, you can have these flat mirrors, but you can put them in a circle so that it will reflect up here. This is not a light. This is sunlight that's reflected into the central location, and the fluids are going to flow up through here and down into the generator area, and you're going to have the same thing. You're going to make the steam, turn the turbine, blah, blah, blah. Okay, so which of the following is not an advantage of using solar energy to generate high temperature heat and electricity? 1, it may disturb desert areas. 2, no carbon dioxide emissions. 3, can be used by individuals. And 4, the source will never run out. All of these things are true, okay? It definitely disturbs desert areas because think about you're out here in this fragile ecosystem, you're building these large-scale plants, right? And so that is a disadvantage, is that the places that you want to put this are going to be places that get lots of sun, for the most part, and those are the places that are these low moisture sensitive desert ecosystems. Now, there are no carbon dioxide emissions from the generation of the electricity or heat. That is excellent. It can be used by individuals. You can have a solar plant on your roof. That's exciting. That's an advantage, and the source will never run out. Renewable, total advantage. So number 1 is not an advantage. It is true, but it is a disadvantage. Okay, now you don't just have to use heat because solar is so versatile. It's very exciting. You can also have solar cells, photovoltaic cells, also called PV cells. And these are the solar cells that you're probably most familiar with because this is what's going to be like in your calculator or in your solar chargers for your phones. This is what you see on people's roofs for the most. If it's not a heater, water heater, it's most likely going to be a PV cell. So a PV cell is going to be silicon. It's going to be this very thin film, semi-conducting material. It doesn't have to be silicon, but most of the time it is. And so you have this thin film. It's got these wires across the top of it that all go to a central wire that are going to be taken to wherever it needs to go. In this case, we are lighting a light bulb. But you have this direct conversion of sunlight to electricity. And this is actually really cool because there's no making steam, there's no turning turbines, there's no turning magnets, none of that. It is based on the photoelectric effect. I mean, it's not based on, it is the photoelectric effect. When the sunlight of certain frequencies will jiggle electrons in the semiconductor, and we know that when we have these moving electrons, that is the electric current. So you're generating the current using this phenomenon, this direct phenomenon. And it's pretty darn exciting. And that makes it really usable because all you have to do is have this semiconductor, and then you just have to have some sort of battery so you can store it for nighttime or when it's been cloudy for a long time or whatever, and then just some way to distribute it to wherever it needs to go. And so it's actually pretty simple. And in this case, you have this house that's got the solar panels built into the roof, and there are actually technologies now where they're working on shingles that are solar generators, and so you would just have the shingles on your house. But let's say that you are not reshingling your roof. You can always do after the fact. I mean, this is a lovely farmhouse style house, and you have these solar plates that have been attached to the roof. Here is a house not unlike many of the houses you see in Dallas. Boom, solar panels right there on the top. And then, of course, there are a lot of industries that are using them. The FedEx plant, for instance, actually generates something over 80% of its electricity with a solar plant on its roof, and it runs 24/7. So that's really impressive. And then here are solar carports. If you had an electric vehicle that plugged in, you could actually plug it into the carport, which is generating the electricity all along the top of it. And that is a really great potential thing to have in the future. And then here, this is really cool. This is the Mountain Ridge Middle School. And I'm not entirely sure of my number, but I want to say that I remember hearing that they had made somewhere around $25,000 back from their electric bill. because they had installed these photovoltaic cells. The other thing about them that's actually really cool is that they are incorporated into the middle school curriculum, and so the kids actually monitor them and maintain them, and that's a pretty neat thing. And this is in Colorado, by the way. Okay. And the other things you can do, there are street lamps. Oh, and right now, school lights, the flashing school signals, school zones, most of those are solar, and so you see it in a lot of places, but there's so much more potential for it. All right, so criticisms against the use of solar energy are going to include the sun doesn't shine very brightly on cloudy days and not at all at night. Much of the U.S. receives too little strong solar radiation, especially seasonally. There's nothing to be consumed, so limited profit can be made, and the technology is still relatively expensive, or all of the above. Well, these are all criticisms. Not all of them are true, though, okay? And so the sun doesn't shine very brightly. Maybe, maybe not. This is what you're going to be investigating in your experiment. Much of the U.S. receives too little strong solar radiation. When we looked at that map, I think there was a lot of solar radiation. So number 2 is going to depend on your results to number 1, actually. There's nothing to be consumed. Well, we already talked about that because you have to produce the panels. They don't last forever. They do have to be maintained. And so there's jobs available there. And then the technology is still relatively expensive. That is actually true right now, but supply and demand. If more people are going to want it, if more companies are making it, then it's going to get cheaper, and that'll be great. Okay. Germany actually currently is at about 20% renewables, and I just want you to keep in mind, think maps, right, because there's a big hint. Germany has about 3% solar. They're actually at about 3.5% hydroelectric, 6.5 wind, and their goal is to have 80% of their electricity for a total 60% by 2050 of all of their energy generation, all done by renewables. We are trying to get like 20% by 2050. And so some countries are more aggressive than others. It just so happens that Germany and the Scandinavian countries and some other European countries, but those are the big ones, the Scandinavian countries and Germany, those are the big ones that are looking at renewables very aggressively. And there's a reason for that. Renewables are better because you have, well, I mean, they're better for a lot of reasons, but here's a really good example. In the blackout of 2003, which you may or may not remember, we knocked out, because of an overload, this entire area of the north and northeast. This is what it looks like normally. This is what it looked like the summer of 2003, and it was blacked out for a while, right? And so you had no electricity. And this actually cost billions of dollars, some for utilities, some for lost productivity. There was $700 million alone in just spoiled stuff from people's houses and grocery stores, all of those perishables that couldn't be kept refrigerated. If cities, so the cost was about $6.4 billion. If cities and private citizens and companies had put in about $3 billion worth of solar panels, a combination of residential and commercial and industrial plants, this probably could have been prevented. Now, I'm not saying that everything, solar is the answer to everything, but it is a great new technology, and it's actually, in many cases, as we already discussed, not new, but it's a great opportunity here that we have to really shift off some of these fossil fuels. So that's it for solar power. If you have any questions, please ask at the next class, and thanks for listening.